Okay, everybody. Before I start, and let me go to the Amazon.com. Actually, I have planned. I have dream, not a dream. I have planned. I plan to sell my books on the Amazon to earn money. To earn money. And sure, so far I still have no time to organize everything, but I will do it maybe this summer. And because students and I we are collaborating to editing some books, and sure, some we use the equipments or devices on campus, and I will share the revenue, the income with the revenue with our campus, because that is the rule. There's a rule. But if student and I we didn't use anything from the campus, we don't need to share the revenue with the campus. There's a policy. Okay, and okay, guess what? Do you yeah? Guys is inside, and I hope they are safe. I hope they are safe. And I bought it from that because sorry. Let me have this issue that 6 sigma print sigma print suppose. Okay, here sigma principles, you can see a lot of books about this issue, and what I show you is double T. Okay, view rate, it looks like this. View rate. I don't know the term how to explain in English, but in our language we call it 低定管. To contain some specific solutions and calculate the volume consumed by the reaction. That is view rate. If are you interested, you can come to our department biology lab to see how to operate those experiments. Okay, then let's come back here. Okay, and the last page of this section is figure 6.2.4, empirical rule, and see approximately 68% of the data is within 1 standard deviation of the mean. 1 standard deviation means plus 1 and minus 1, and this area is about it means roughly, approximately, not exactly, not precise. Okay, then roughly, okay, approximately 68% of the area is covered by this one, and this one is 95%. 95% is about plus minus 2 standard deviation. Actually, exactly to say this is the mean plus minus 1.96, not 2, but roughly we call it 95% is covered by plus or minus 2 standard deviation. It's not 2, it's 1.96, but we just memorize the big picture. We don't need to this moment we don't need to memorize the details. And plus minus 3 sigmas, and that is covered 99.7% of the data. Okay, then next we can see finding probabilities for the normal distribution. Okay, and here is z-score. I think sometimes this score is you can study a little bit like this, and especially we can use a lot of software or online applications. This score, okay, here definition of this score, where mean, the micro is the mean of the population of X value and sigma standard deviation for the population of the X value here. And this score try to standardize it. The z-score is normally distributed with a mean of 0 over 0. Actually, it's kind of transformation. Well, when we talk about transformation, there are many meanings. One is the movie. Let me show you. Transformation, there are a lot of meanings, and okay, I didn't transformation. Okay, there is a movie. There's a movie, the name is Transformation, and in Taiwan we have a beautiful translation. It's called 变形金刚. What a fantastic name. Okay, actually it's Transformation. And now I want to talk about the transformation. To transfer your normal distribution information, the data, into a z-score, and the z-score, everything can be standardized as a z-score. That the mean is 0, and a standard deviation is 1, and the transformation formula is look like this: z equals x minus mean divided by a standard deviation. Okay, you have a concept that's enough. This time you don't need to remember the formula. Okay, then in other words, when for example, the height of female, the body weight in Taiwan, we believe it can be a normal distribution. Sometimes for a better calculation, we can transfer that, we can convert the information into z-score. That will be easier to operate the following calculation. And now the z-score, the mean is 0. Plus 1, that's 1 standard deviation. Minus 1, that's 1 standard deviation. That is the definition of it. Okay, and this part is easy. And okay, let me have a look at this. Okay. Let me give you this website, and you can. Okay, I think this one or this one. Oh, okay. Maybe the first one is okay. Okay, let me go to the next paragraph. And here, example 6.3.1, general normal distribution. The length of a human pregnancy is normally distributed within a mean of 272 days with a standard deviation of 9 days. Okay, and it's a real data. Okay, again, when I was a baby, not a baby, when I was a embryo in my mother's body, okay, and I lived about 272 days after that. I was born, and the standard deviation is about 9 days. Okay, then state the random variable and find the probability of pregnancy lasting more than 280 days. And find the probability of pregnancy less than 250 days. Okay, like look at this. Okay, solution: X is the length of a human pregnancy, and first translate the state into a mathematical statement. When probability is greater than 280, Now draw a picture. Remember the center of the normal curve is 272, 272. And here, what's the probability? What's the probability? And now we don't need to use the formula. I will tell you how to use this. The probability here is here. Okay, it's about 0.187. It's about 0.17. And here I want to. The mean is 272. The standard deviation is 9. What's the probability more than 280 when I use this? The mean, okay, and the mean is 272 days. Standard deviation is 9 days. And above 280, calculate. Okay, the result is 0.187. 0.187. So please go to my website here. We use this. Okay. We use this website. Normal distribution. That is from, where is it? Okay, here. Okay, then we use the information from 6.3.1. Okay, let me copy that to your line group, the line group. 1 minute, please. Okay, and the example is here. Excuse me. Okay, and maybe here is okay. Copy. Paste. And please, you may use your own, but I suggest that we can use the online applications. That's easier for us. Okay, and again, let me show you. Please. Or you can go to my website for the syllabus. Week 14, May 22nd. Besides the cell phone, you can use some free applications online. Here, I encourage you to use the hackmath.net. Okay, then select the information. The keyword mean 272. Standard deviation is 9, and find the probability lasting more than 280. Then go to this side. The mean 272. standard deviation is 90, and we try to find the above. Please insert 280. Then you will see this picture. We will see this picture. Then that's important. Let me explain it. Over 280, it means the probability is about 0.185. It means the probability is not big. It's not big. And then take a screenshot. Take a screenshot of these and these. The information is here. Then next, you can find the probability of a pregnancy lasting less than 250. Less than 250, then you can select your information here. Below 250, calculate. Wow, that is very small. The number is 0.00373, like this. Okay, please do this part. You can use 2 minutes to this. And if you have question, please let me know. And this one, when I was a PhD student, the moment we didn't have such online applications, but now we have the online application. We don't need to waste our time to do something, because in the past we need to check the table, because the table is a big table with maybe hundreds of numbers. Then we find this area and subtract this area. Then we found this area. that is horrible. That is horrible. But now we just input your data here, then you will get the probability, the area of this. Okay, try it, and if you have question, I will demonstrate again 5 minutes after now. Any question, please let me know. I remember I'm going to send you the posters we have done in the past 2 years. Get 1 minute, please. Let me. Oh, come on. I made a mistake. I sent it to the wrong line group. I'm sorry. I'm tired. Oh, okay, then go to the next question here. Okay, find the probability that pregnancy is between 265 and 280. 265 and 280. Then go to the between 265 and 280. Calculate. The probability is 0.59. 0.59. It's very convenient to use the online applications because when I was a PhD student, it was it's not difficult, but we need to check the table again and again and subtract different area to get the answer we need. So I will not teach you this part because now we have convenient applications here. You don't need to waste your time to do something nonsense. I think this part is really easy. It's really easy. Okay, and next question. Find the length of pregnancy that 10% of the pregnancy less than no more questions. Okay, suppose you meet a woman who says she was pregnant for at least than 250 days. What will be the unusual and what might you think? What you might think about the pregnancy? Okay, that's one thing because the average is 272 and the delta deviation is 9. If less than 250, the probability is not big. Here, below 250, and the probability is really big. Sorry, the probability is really small. Can you see it? Where is diagram? Again, on this condition, from the real data, and the average of pregnancy is 272 days. The average is here, and the standard deviation is -1, and -1 again. -1, that's 263. -2 standard deviation, that's 254. And if a woman said, okay, my pregnancy of my baby, that was 250. See, the probability is really, really low. Really, really low. And in the future, you can calculate something like this. Okay, and any question about this part? Okay, and can you show me your screen and let me check? Is everything okay? This one? This one? Can you check a picture, screenshot? Hey, that like it. Christine, yeah, you did a good job. And yeah, like this. Yeah, good. In the future, I will tell my colleagues, Dr. Yuta, hey, see, they did a good job like this. So you need to spend a little bit of time to edit your homepage like this. Hey, good. 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 Yeah, good. And you can select different information. That is also good. But you need to cite. Cite, it means you need to place the source, the link from the picture. Then you can understand it. Okay, good. Let's move to next step. Okay, then, oh, this example is a little bit sensitive. Ooh, like, okay. The mean mathematical set, SAT, is not a Saturday. It's about the American style testing or exam. For example, when I was a master student, when I was ready to apply for the PhD from the US, I attended TOEFL, the English exam, and GRE. That is for the field of scientific students. And there's a kind of IQ test, very similar to IQ test. Okay, the score in 2012 was 514 with a standard deviation 117. Total group profile, okay, then the data is from 2012. Assume the mathematics set score is normally distributed. Okay, it's a normal distribution. And now state the random variable. Second, find the probability that a person has a mathematical set score over 700. Again. Sorry, let me. Okay, I use different screen and I think it's easier to watch the data simultaneously. Okay, then the second screen here, normal distribution calculator, the mean is here 514, 1, 5, why no response? 514. Standard deviation is 117. And now the question is find the probability that a person has the mathematical set score that is over 700 and it means above 7. Then click calculate. Ta-da. then what we get is like this. The probability is 0.0559. We can call it the top 5%, the elite, or the top 66%, the elite. Again, the SAT score, the mean 114, type 114 here, that is the mean, and type 117 here, standard deviation. And the question, the score over 700, what's the probability? The probability is 0.0559, very close to 6%. Okay, 1 minute, please do this part. Then we can go to the next. Questions? Sure. Tonight, I will go to buy lottery. If I won the first prize, I will buy a new projector. I will bring my own new high quality projector, not this quality. Sorry that you know sometimes the projectors are getting aged, then the resolution is a little fuzzy, not so clear. Sure, if I had chance to win the first prize of the lottery, I would donate scholarship to our students in China University. You can go to Hawaii, but I would donate part of the prize to be a part of the scholarship to our students.
I will donate 1/3. The rest of it.
1/3. There's a very high ratio. Okay, then the next question, find the probability that a person has a mathematics state score of less than 400. Less than 400. The same operation, mean 514, the standard deviation 117, and this time we select below, I cancel it, below 400. Then click calculate. Then the probability is 0.1649. What does it mean? It means during the in the among the big population, students who attended the exam, about 16% of it, their score were below 400. Okay, get it? Okay, the next question. try to find the person has a mathematical state score between 500, 650. We can use the website here. Between here, 500, 650, and click calculate. Then we get the answer is here. Then the probability is 0.4251. If you want to know how do we operate the calculation in the past, I will tell you. You will think that's stupid. No. The moment very few online applications like this. Now it's very popular. I think it's a kind of advanced. Someone released those for free. Okay. Last question. Find a score that represents the top 1%. Oh, that's elite. Best of the best. Now, I mean only in this field about the exam. Okay. 1% of all scores. Okay. What is the score? That will cover 1%. And from this one, it has no function, no blank for this purpose. So I would like to suggest you can use above. You can try maybe 700. Calculate 700, 0.5, 0.05. That's not enough. 750. 750, the area here, is it 1%? No, that's 2%. Then you can put a little bit more. 800, 800, click. 800, that is less than 1%, maybe a little bit lower, maybe 790. 790, that is very close, maybe 788. 788, very close. 785. Yeah, very close to 785. Because on this website, it has no function to calculate percentage. So we can try one by one. Very close. 785, that is close to 1%. It means the average of the score here, then about 785, the score is very high, and over this score, there's 1% of the whole population of the student who took this exam. I remember when I was a master's student, I took the TOEFL exam. I think I'm close to the average, but maybe a little higher of that. Okay, 2 minutes, we can do this part, then we can move to next question. Sure, about this part, I think in the final exam, I will prepare the similar question like this. I think it's easy. I think it's easy. 0.01%. So what's the score? 86. Okay, thank you. 786. Okay, thank you, Daniel. 786. Okay. Oh, get it. Thanks. Yeah. It's a trial and error, and you are approaching to the real value to the requirement. Oh, thank you, Daniel. 786. Oh, okay. I have extra question for you. And my question is, we can watch this part. The mean is 514 here, and plus minus 1 standard deviation is here. I have a question. Can you set the calculation? You can use the function between 397 and 631. Please try this part and tell me what you will get. Between 379 and 631 and calculate. Oh, sorry, I downsized the screen. Otherwise, there are 3 digits, not the 2 digits. Again, we want to find, because the computer automatically calculate the mean plus 1 standard deviation minus 1 standard deviation. Thus, the value is 397 and 631, like this. And after we check this area, the probability is 0.6827. It means this area is 68% of the whole area. Also, it means the probability. $1, did you join the SAT mathematics exam? Yes, I did. So, what's your score? I said very, very close to the normal distribution. I'm not smart, and I get it like this. Okay, and next question. You can use the function outside. It's 2 tails. You can type the same 397, 631, and see what you will get. Outside 397, 631, what you will get. Okay. Now we use a function between 397, 639. Thus, we can see the area, the blue area, between those 2 values. And now, use the next function, outside. You will see the blue area in the left tail and right tail. So, what's the results area? You can imagine that is 1 minus 0.6827. That will be the answer. Okay, let me type outside 397, 631, and calculate. That answer is here. Okay, have a break. See you later.